In this video, we will discuss the problem maximum GCD of sublinks of a binary tree. The problem says that we are given a 2D list, that is, we have been given a 2D array which represents the nodes of a binary tree with n nodes. So total n number of nodes are there in the binary tree, and the task is to find the maximum GCD of the siblings of this tree without actually constructing the tree. And suppose that if there are no pairs of siblings in the binary tree, then if in that case you have to print the GCD as 0. And also it has been given that if there is an edge between A and B and it is given like this, A comma B, then A is the parent of the parent node. Suppose if it has been given like this, suppose the node has been in the 2D array, it has been given one by one like this, 1 comma 3, 1 comma 4 like this. So in this case what will happen, 1 is the parent of 3 and 1 is the parent of 4. So you can see like this. This will be the case. So if A comma B has been given, so it says that A is the parent of B. This is the case. Now in this problem, the thing is that you have to do it without constructing the actual binary tree. So let us say that if a situation was given, where you have been given the sequence. So let's say if you were given 2 comma 3, then you were given, let's say, 4 comma 5. Then let us say that you are given 2 comma 1. Then let's say you are given 4 comma 2. Then after that you are given 3 comma 6, and after that you are given 3 comma 12. So in that case, how will we construct the tree? So we can see that we'll be constructing the tree starting from 4, because 4 is the root node. So 4, as it has been given in the example as well. So 4 and 5, and for 4 the 2 is also a child. Then after that, what will happen? For 2 the child is 3, the child for 2 is 1 as well. Then for 3 the child is 6, and for 3 the child is 12 as well. So this is the binary tree that we have drawn. Now in this case you can see that 5 and 12 are siblings. So the GCD of 5 and 2 are siblings. So 5 and 2 GCD is 1. Then the GCD of 3 and 1. The GCD of 3 and 1 is nothing but 1. Right. After this you can see the GCD of 6 and 12. The GCD of 6 and 12 is coming out to be nothing but 6. So that's how the maximum GCD out of 1, 1 and 6 is nothing but 6. So that is what you will store. But in this case, the problem says that you do not have to construct the actual binary tree and you have to find it without doing that. So how can we do that? So you can see that this 2D array that has been given to us, it will be kind of unsorted in fashion. And let's say what for the ith row, like array of 0 and array of 1, array of I0 and array of I1, if it has been given. So this says that the first value will be the parent and the second guy is going to be the child. Okay. So how do we check for all the parents? I can see that if the 3 and 1, between 3 and 1, the common parent is 2. So I need to bring the parents together. So how can I do that? So the thing is that I can sort this array up. When I sort this array, so what will happen? I'll tell you. So suppose that I start sorting this array. So if I sort this array, so what will happen? Then I can say that the nodes will get sorted. So the first, like you can see that sorted order will be what? 2 comma 1. Then it will be nothing but 2 comma 3. After that it will be what? It will be nothing but 3 comma 6 and then 3 comma 12, and after that it will be what? It will be 4 comma 2 and then 4 comma 5. So you can see that after I have sorted it according to the first value, and then if the first values are the same, then the second values will be taken care of. So you can easily see in this case that the thing is that after I sort it, so the parents, you can see the first value is representing the parents. So all the children of the parents come adjacent. You can see that 2 comma 1 and 2 comma 3. So that means this node and this node are now adjacent. So if the array of I0 and array of I plus 1, if the array of I0 and the array of I plus 1, 0, if they are equal, in that case what I can say is, I can say that I can find the GCD between the two, because these two will be the siblings, right? These two will be the siblings. So let us try and find the siblings. So I can see that these two values are same, 2 comma 1 and 2 comma 3 are same. So the GCD will be what? The GCD will be 1, and up till now the maximum GCD is also 1. After that what will happen? I'll check for the I and I plus 1 again. So I'll check for 2 comma 3 and 3 comma 6. So since they are not having the same parent, so since they are not having the same first value, so I'll not consider them. After that I'll consider 3 comma 6 and 3 comma 12. So here the GCD will come out to be 6, right? Here the GCD comes out to be 6, so I'll update my GCD, maximum GCD to 6. After that what will happen? I'll check for the next. So I'll check for 3 comma 12 and 4 comma 2. So the parents are not the same, so I'll not calculate the GCD for them. Then after that I'll calculate the GCD for these guys. So the GCD will come out to be nothing but 1. So I can see that the maximum GCD up till now is nothing but 6, and that is what I'll return in the final answer. Right. So this is how I'll be doing it. And you can notice, like, you have to notice some of the edge cases in this problem as well. Suppose that if there is just one node, right? If there is just one node, one node given. So in that case, if there is just one node, so there will be no siblings, right? No siblings. So in that case, I'll return 0. Or if there are two nodes, so let's say 1 and then 4 is there. So here also you do not have any siblings. So here also you will return 0 in these cases, right? So that is what you will be doing. Now let us try and implement the code for this particular problem quickly. So what we will be doing first of all is we'll be checking the edge case first of all. That if it happens that the n is equal to 1, or it happens that n is equal to 2. So if there are just one node, or there are just two nodes, in that case I will not have any siblings, so I'll return the answer as 0. Otherwise I'll have the int answer initialized to 0, and what I'll do is I'll sort the 2D array that has been given to me. So I'll sort array.begin, array.end, and after that what I will be doing is, after I've sorted it, so I'll start my iteration. So I'll start for int I start from 0, I is less than array.size minus 1. Why? Because every time I'm checking for I and I plus 1, so that is why I'll be running 1 less. Okay, after this part what I will be saying is that if it happens that array of I array of I 0, right, array of I 0 is equal to array of I 1, array of I plus 1, array of I plus 1 0. So if the current and the next guy is the same, in that means the parent is the same, right? That means this is the condition for sibling. Like when array of I 0, when the ith guy and the I plus 1th guy, the 0th coordinates are same, in that case that means that the parent is the same. So that means the array of I 1 and the array of I plus 1 are siblings, right? So this is the condition for siblings. In that case I'll calculate the siblings. So I'll say that answer is equal to nothing but maximum of answer, comma, I'll calculate the GCD. So GCD will be underscore GCD of array of I 1, comma, array of I plus 1. So that is how I'll calculate the GCD, and this is how one by one my maximum GCD will get calculated and updated, and in the end I'll return the maximum answer. Let us try and compile this code to see if it works on the samples. So it is giving some errors. So it is saying int I is equal to 0. Okay, so some of the errors are here in this code. Let us try and debug them. So basically it is saying that I was not declared. Okay, so I should declare this as for loop was not declared correctly. Now let us try and compile this to see if there are any other errors. It seems to work on the samples. We are getting the output as 6. Let us try and submit this code. So you can see that our solution was able to pass all the test cases. And in this problem, the thing is that since we are applying the sorting approach, without constructing the binary tree, we are doing this as we were asked to do. So since we are applying the sorting approach, so the time complexity will be n log n, right? Because there are n is the size of the array, and the space complexity will be nothing but order of 1, because we are not using any extra space. In case if you like the solution, so make sure to hit the like button and comment down understood in the chat as well. Thank you.